Hi everyone, welcome to the session. So, already in the previous session, we had seen the problems how to reduce the resistance by number of methods. Now, let's try to solve the resistance reduction method using which includes star to delta transformations. So, this is the circuit given to us. He is asking us to find out the resistance between R, X, Y. So, how to handle this problem? Let's try to do it. So coming here, you can see here this inner branch constitutes an star network. Let's try to convert this star network into an delta network. So I'm redrawing the circuit diagram. So here I have an X node with the original branches 5 ohms, and I have the next original branch here as Y node, and this is connected like this, which constitutes again 10 ohm, 10 ohm, 5 ohm, 10 ohm. So I'm going to handle this, convert this star to an delta. So when I convert the star to a delta, I'm going to get the delta format like this. This is one element connected between these two, and this is another element which is connected, and this is another element which is connected. So now we need to find out the value of this resistor. You see here we need to convert these two, which is nothing but this element. So how to convert is so when you want to find this value, we know the formula that so this is the element what we require, and this is the element what the next one we require, and this is the element what actually we require. Here how to find this element. So how to find this element is so this red color one is connected between these two resistors, so the formula is 2 plus 2. So 2 plus 2 divided by into the product of 2 into 2, and the branch which is connected to this resistor what is connected 90 degrees is by 2. So when you perform it, so this is nothing but this value is equal to 6 ohms. This value is 6 ohm. Similarly, when you perform this finding this red color resistor, finding this value, so I want to find out this red color one. So what are to this red color branch, what are the resistors connected? 2 ohm and 2 ohm. So how to do is, so 2 plus same formula, 2 plus 2 are two limbs connected plus the product of these two. Product is 2 into 2 divided by what is the resistor connected in 90 degrees to this is nothing but 2. 2 will get cancelled out, and here also you are going to get 6 ohm. And similarly, I want to find out this resistor. So how to find this resistor? So how to find this resistor is this red color resistor we need to find is connected between 2 ohms and 2 ohms. So I can write down this as 2 plus 2 plus, so product of these two resistors, which is nothing but 2 into 2 divided by 2. This resistor we need to find out what is 90 degrees divided by 2, where we are going to get 6 ohm. Already as per the concept we dealt, when you have an star network converting into an delta network, if the resistor values are R, then automatically you can write down R into 3, where you are going to get is nothing but R3 ohms. So for example, here in this problem, R value given is 2 ohms. 2 into 3, each branch is of 6 ohm, 6 ohm, 6 ohm. So directly you can use the shortcut of solving this problem. So now coming to the further reduction, so you have this X connected, you have the Y connected here, and you have one resistor here, and you have one more resistor here, and you have the one more resistor here. He is asking us to find out the resistor between X, Y. So you can see here, so I can say these two branches are connected in parallel. Why? Because the current is dividing, and I can say these two branches are also connected in parallel. These two branches are connected in parallel, and these two branches are also connected in parallel. So when you perform this parallel, this is what is this value? So product of resistance 6 into 10 divided by 6 plus 10. So when you perform this value, you are going to get this value as a 3.75 ohm. So you can get this value. So here also same, product of resistance is 5 into 6 divided by 5 plus 6 is nothing but 5 6 are 30 divided by 11. So when you perform it, you are going to get this value as 2.72 ohms. And already from this you can see here these two are of same. So 6 into 10 divided by 6 plus 10, which is nothing but 60 by 16. When you're going to perform, you're also going to get the same value, which is 3.75 ohms. Going depth, the next step what are going to involve is so this is one resistor which is nothing but 3.75 ohms, and here you can see here the current is entering and the current is dividing. So the same current flows across 2.7 ohm and the same current flows across 3.7. I can say these two resistors are connected in series connection. So when they are connected in series connection, I am going to get and so this resistor is connected between the nodes x as well as y. So this you are going to get so 2.72 ohms divided by 3.75 ohms. When you add these two, you are going to get as 6.47 ohms is the resultant value. And again here you can see this, these two are current is entering, current is dividing. I can say these two branches I can say these two branches are once again connected in which connection? Parallel connection. These two are in parallel here. So we are going to get the resultant like this. So connected between x and y. So what is the formula for parallel is product of resistance 3.75 multiplied with 6.47 divided by 3.75 plus 6.47. If you perform it, you are going to get this value as 2.374 ohms. So this is the resistor between R, X, Y. So this is how we solve. So let's recall the problem how we are done. So the given problem is in the black color, and we are converting the internal star to an delta, and we are finding out this delta value. So when you find this delta value, you will be getting this is 2. As per shortcut, you have to perform a star to delta, you can perform by scaling 3 times. Therefore each resistor will be 6 ohm, 6 ohm and 6 ohm. Now these two branches are in parallel, these two are in parallel, these two are in parallel. So therefore you are going to get this resistor 1, 2, 3. And after seeing this connection, you can see here these two are once again connected in which connection? Series connection. So after that you draw a single resistor, and again you can see this, these two are once again connected in parallel connection. So the resultant value what is asked in the question, the value of Rxy is equal to 2.374 ohm. The concept you have to note here is when you have resistors connected in star connection, when you are converting into an delta connection, the resistors are of equal value. The equivalent resistors in the delta will be multiplied by 3 times. Here it is 2, so here it is 6, 6, 6. So that is what the main point you have to understand in this concept. Let's try to solve the next problem in this resistance reduction techniques. So the question given is find the equivalent star. So find the equivalent star for the network shown below. So the network given to us is like this. So you have one branch and a parallel branch is also given, and you have one more branch and a parallel branch is also given, and one more branch is given like this, and they had given one more parallel branch. with 6 ohm, 9 ohm, 6 ohm, 9 ohm, 6 ohm, 9 ohm. So he is asking A, B, this node is given as C and this node is given as D. And you can see here this B, D all are same connected with grounding. So how to solve this problem? So coming to the first step, so we are going to convert this into an equivalent source. So you can see here this will act as one resistor. So I'm taking node A, I'm taking node B, L S plus D remain same. So here I'm going to get one resistor to this node, and here I'm going to get one more resistor. So connected between A, B and D, and this is which node? C node. So I can see here all these are connected in parallel. So when they are connected in parallel, what is this value of this resistor? So this is nothing but two are connected in parallel. 6 into 9 divided by 6 plus 9. So which is nothing but when you calculate it, you are going to get this value as 3.6 ohms. This also will constitute 3.6 ohm. This also will constitute 3.6 ohm. So further simplifying it, so we are going to get one resistor like this between A and B, and you can see here the current is dividing between these two resistors, and the same current flows across 3.6 and 3.6. There is no division of current. I can say these two elements are connected in series connection. These two elements are connected in series connection. I am drawing an equivalent for this series connection, and I am writing this value as 3.6 ohms. So these two are connected in series connection. So if you want to find resistance between R, AB, so but the question given here is we need to find out the equivalent star. So here you can see here this is connected in the form of an delta. So when you perform this, you are going to get as 7.2 ohm, and these are once again in parallel. Then you can find out if the question asked is the resistance between RAB. So it's nothing but parallel combination 3.6 into 7.2 divided by 3.6 plus 7. But the question is a little bit they want the value of star equivalent. So now we need to convert this network into an star network. So here you can see here this is connected in the form of delta, and we need to find out the star, the black colored one we need to find out. So I am redrawing it with node A, node C and node B, and I want this value with a neutral, and I want this value with neutral, and I want this value with neutral. So you can see here what is the value of this. So you want this element, and this is nothing but conversion of delta to star, and you can see all the values are same. Let's try to do by two methods. So when you want to find the center value, the formula is 3.6 into product 3.6 into 3.6 divided by 3.6 plus 3.6 plus 3.6, sum of resistors which are connected in series. So when you perform it, you are going to get the value of 1.2 ohm. The same concept here. So we need to find out the distance between these two. The black color we need to find out is connected. The black color resistor we need to find out, and we can apply the same formula here, and same formula is also applied here. So which is 1.2 ohm, 1.2 ohm, and we already know from the basics when you are having an delta connected system and we want required star connected system, we can make these values as a by 3. So the given value is 3.6 are equal resistors 3.6, 3.6, 3.6, and we are performing by 3. When you perform it by 3, then you will get it as a 1.2 ohm, 1.2 ohm and 1.2 ohm. So like this Our answer is this one. If you feel the content is useful to you, so please like, share and subscribe the channel. Thank you.